All right, so here's 7.2 stoichiometry. And again, as I mentioned in the last video, what I'm trying to do is break down stoichiometry for you guys in little tiny bite-sized, very manageable, digestible steps. And so the only topic covered in 7.2 was mole-to-mole conversions. And again, I use an analogy for sandwich making because we understand sandwiches. We understand baking. We understand making stuff in real life. When it comes to chemistry, we get confused because it's abstract and, we don't make chemicals on the daily. And so, but hopefully, please come back to this idea of sandwich making, because if you understand sandwich making, just try to connect the dot from this dot that you understand to the dot of chemicals and chemistry and chemical making, which you don't understand. I promise you, it'll help you if you think in terms of analogies. And so let's go look at this analogy first in order to connect that dot. And here, again, we have that same situation where, hey, two pieces of bread with one piece of cheese combined to make one sandwich. And now that I think about this, it's a pretty bland sandwich, but bland, easy to understand. And so if we're making this bland sandwich, how many sandwiches can we make if we have 4 pieces of bread? Right, so if we have 4 pieces of bread, how many sandwiches can we make? Now, some of you, as soon as I ask this, you're like, oh, 2 sandwiches, right? How do you get that? Well, here's really what you're thinking of in your head. Let me break down your thought process. What you're saying is, well, I have 4 pieces of bread, and how many sandwiches is that? How many sandwiches am I trying to make? And you're like, well, it's 2 pieces of bread for every 1 sandwich, and so, therefore, 4 divided by 2 is going to be 2. That's really what you're thinking in your head. What I'm doing is I'm just formalizing it, but that's what you're thinking. What you're doing is you're using a ratio that tells us how things combine, and you're looking at what we start with in order to get how much we can make, right? That thought process is at the heart of stoichiometry. That's what stoichiometry ultimately is. You use a ratio to figure out, based on how much you have, how much you can make. Okay. So let's now look at chemical making and apply that same logic. How many moles of HCl will be produced when 2.3 moles of PCl5 react with an abundance of H2O? And now that word abundance, I'm using it in the same way that I used here, assuming you have more than enough cheese, right? What I'm trying to say is, hey, don't worry about the number of cheese running out and thus limiting us, right? Because technically, if you have 0 cheese here, then you really can't make a sandwich, right? Because you just have bread, but no sandwich, right? And so, but don't worry about that, okay? We'll add that on in 7.4 when we talk about limiting reactants. But for now, just, hey, assume you have more than enough cheese. Here, assume that you have an abundance of H2O. Don't worry about this running out. Just, hey, if you have 2.3 moles of PCl5, how much HCl can you make? Use the exact same logic from sandwich making. Let's think, right? Well, if I have 2.3 moles of PCl5, how much HCl can I make? And sorry, I'm gonna write moles of HCl. How many moles of HCl can I make? Well, every 1 mole of PCl5 is going to be able to produce 5 HCl's. And so in that situation, 5 times 2.3, that's going to be 11.5, right? Exact same logic, right? What we did here is, again, we used a ratio, right? This is what we call the mole ratio. And we use that to go from, hey, what do I have? What do I want to get to, right? Multiply by a ratio. What do I have? What do I want to get to? Use a mole ratio, right? It's the exact same logic. And so this is how you would do mole-to-mole conversions. You start off with what you have, you write what you want to get to, and you just use the ratio in order to multiply it out. Now do note, again, we wrote 1 mole of PCl5 on the bottom because we wanted to cancel out the moles of PCl5 on top. So you have to put it that way. So here's a big tip / exhortation / beg. Please use your units. Write out units. I'm not saying this to be annoying. I'm saying it because if you write out your units, you'll never get confused. Here's the problem. A lot of students will be like, 2.3, the ratio is 1 to 5, and they'll write out something like this. They'll be like, 1 over 5, and then they'll do 2.3 divided by 5, which I don't know, and I don't have my calculator on me right now, right? But it'll be close to like 0.5. And they'll box that. And then they'll get it wrong, and then I'll mark it wrong, and they'll be like, wait, how? I don't understand. I'm so confused. And I'm like, well, yeah, because you didn't write out your units. So of course you don't understand what the heck you're doing, right? You just multiply it by 1/5, and you don't know what these numbers mean, right? So please write out your units, not for me, but for you, because then you'll actually understand what you're doing. You'll see, hey, the moles are canceling out here, and then that's how I get this right answer, right? So please write out your units. Do not do this. You will be sad, and I will be sad for you, and everyone will be sad. So please, just write out your units. I know, it's a lot. And actually here, even I didn't write out my units fully, right? Please write moles of HCl or moles of PCl5. This will be important, especially as these things get more complex as we go into 7.3. So write out your units, and then if you do write out your units and you do this, everyone will be happy, and I will be happy, and you will be happy, and your parents will be happy. And what a vision. Please write out your units. Cool. All right. Come by whenever you need help.